Welcome to the Deep Dive. Today we're looking at something you might think is pretty simple, maybe even obsolete, the abacus.
Right, but it's so much more than just an old counting tool.
Exactly. We're going to explore how this is genuinely, well, the ancestor of modern computing. It really laid the groundwork.
That's the mission today. Not just what it is, but why it mattered so much back then, and how its core ideas still pop up in, the devices we use constantly.
Okay, so let's get into it. What exactly is an abacus? Most people picture the frame with beads, right?
Yeah, that's the common image. Essentially, it's a counting frame with rods and movable beads. It was used for arithmetic addition, subtraction, multiplication, even division.
And this was long before calculators, obviously, but even before written numbers were common everywhere.
Absolutely. And its roots go way, way back. We're talking ancient Mesopotamia, Sumeria, maybe around 2300 to 2700 BCE.
Wow, that's ancient.
It is. Sumerian merchants used these counting boards, sometimes just marked lines in sand or grooves in wood, and they placed pebbles on them.
Pebbles. Okay.
And those pebbles had a name, calculi.
Wait, calculi, as in calculate.
Yes.
Seriously?
That's the root. It's right there in the language. Shows how fundamental this was.
That connection is incredible. Okay, so it starts in Sumeria.
And the idea spreads and evolves. The Egyptians had stone tablets for counting. Then the Greeks developed something called the abacus.
Abacus.
Yeah, basically a counting board, again, using pebbles or markers on lines. Very similar concept, really laying down that idea of positional value.
So different cultures adapt the core idea.
Exactly.
Right.
And then you get the Chinese swan pan emerging around, say, 200 BCE. This one is often what people picture the frame with beads on rods.
Right, bicycle.
Typically, it had 2 beads on the top part of the rod and 5 beads below. This setup was really versatile for decimal calculations, even more complex stuff like square roots.
And they still teach it?
Oh, yeah, in some parts of China, it's fantastic for developing mental arithmetic skills.
Then the Japanese adapted it too, right? The Soroba.
Yes. Around the 1600s CE, they simplified the Chinese design, usually to 1 bead above the bar and 4 below.
Easier for base 10.
Exactly. Optimized for the decimal system. The soroban became hugely popular in Japan, used in schools, and you still see it in mental math competitions. Kids get incredibly fast.
Faster than a calculator sometimes, I've heard.
Skilled users, especially with mental training, definitely. It's amazing to watch.
And it wasn't just Asia. Russia had one too.
The soti, developed around the 17th century. It looks a bit different, usually laid flat with beads moving horizontally on wires, typically 10 beads per wire.
Ah. Okay.
It was ubiquitous in Russian shops and for accounting right up until calculators took over in the 20th century.
So across all these variations, what's the key principle? How does it actually work so effectively?
It all comes down to place value. Each rod represents a different power of 10 units, tens, hundreds, and so on. Moving the beads represents adding or subtracting quantities in that place.
And the real genius is handling the carryover, isn't it?
Precisely. When you fill up one rod, say you reach 10, you reset that rod and move 1 bead on the next rod over. That's the same fundamental algorithm a computer uses for addition.
So it's like a physical representation of a digital process.
In a way, yes. Each bead's position encodes numerical information. It's a tangible way to manipulate numbers according to set rules. That's computation.
Okay, so beyond mechanics, why was this so important for civilizations?
It was transformative, think about it. It allowed for standardized trade, accurate tax collection, managing inventory, basically the administration of complex societies.
Essential stuff.
And crucially, it helped teach abstract mathematical concepts. It was the very first tool that really let people see and manipulate numbers physically, moving beyond just counting fingers or making marks. It abstracted the idea of quantity.
That physical manipulation, that's the link to computing you mentioned.
That's the core link. This idea of representing numbers by the position of physical objects and manipulating them according to rules, that's the foundational logic behind mechanical calculators and eventually digital computers. It's about state and operations.
And it's not entirely gone, is it? You mentioned it's still taught.
Not at all. Shopkeepers in parts of Asia and Africa still use them daily. And as a teaching tool, it's fantastic for helping kids grasp place value and number systems.
Plus the cognitive benefits, memory, concentration.
Absolutely. Studies have shown that mental abacus training, visualizing the abacus and manipulating the beads in your head, really enhances those skills.
So its legacy is huge. It's not just a historical artifact.
Far from it. While we have silicon chips now, the underlying logic representing data through position, performing operations by changing states, that fundamental thinking owes a huge debt to the abacus. It truly taught us how to build machines that handle numbers.
It's pretty mind-blowing. From these
Yeah.
simple beads and rods, you can draw a direct line to, well, the entire digital infrastructure we rely on today.
It's a profound connection, such a seemingly basic invention holding the seeds of something so complex.
So recapping, we've journeyed from ancient Sumerian pebbles to sophisticated calculating tools that shape trade, math, and ultimately the very logic of computing.
We have. And maybe a final thought for everyone listening. Think about the technologies you use every single day. How many of them, deep down, rely on principles as fundamental as the abacus's logic of position and manipulation?
That's a great point.
And what other, maybe overlooked simple ideas or tools from our past might just be waiting to inspire the next big leap forward? Something to ponder.